Let's recap database normalization. Now, why do we have it? Well, it's the efficiency and the integrity of the relational database that's at stake. We want to avoid data duplication. So in other words, having the same data stored multiple times in the database for no reason. We also want to ensure that there is no data redundancy. This is where we might have the same data stored in multiple different ways in the same database, such as a first name field, a last name field, and a full name field. We don't need the full name if we've already got the first and last name, for example. So what we'd start is with an unnormalized form. This is just the big brainstorm of what it is that you want to store in your database, and expect that this will be added to and maybe deleted some items as you go through. So here's an example of an ordering system for a bookshop. We're going to store data about the customer, what they've ordered, information about the books themselves, all that kind of thing. But you can see straight away we've got a couple of problems. The most obvious one is that in fields like title, author, genre, year published, and price, we're actually storing multiple data entries for the first and the third record compared to the second record, where we're only storing one data entry in both. Now this is an example of repeating data, and we want to avoid it. So in first normal form, what we want is to ensure that we have every single table in the database adhere to these four key things: unique field names, a primary key, the data is atomic, and we have no repeating data. Now at the moment, this sort of unnormalized table that we have here only satisfies the first of these four criteria. All the field names are different. What we're missing is a primary key. What if I had two Jane Smiths, for example, or two Programming 101 books? I've got no way to identify each record. Likewise, things like customer name and author should really be broken down into the separate first name and last name attributes. And then obviously in this case, wherever we have multiple entries in the same cell of the table, so to speak, that's where we've got repeating data. If I wanted to look up all the books by Marge Simpson, for example, there is no entry in this table for Marge Simpson. The entry is Tim Brown, Marge Simpson. And I'm not going to be setting up an SQL query to search Tim Brown, Marge Simpson when I only want one person's name. So the first thing we need to do is add a primary key. But then we are also considering the bigger unnormalized table of, is this table storing data about more than one thing or entity? Conceptually, if it is, then we need to break it down into smaller tables. So at this stage, for example, I've broken it down into a customers table with cust ID as the primary key, and the books table with book ID the primary key. Now when we look at every single cell in the table, we have no repeating data. There's no cell with multiple entries. We've got a primary key. All the data are now atomic. We've split the full name into first name and last name. And all of our fields, as they were before, are unique. Now in second normal form, we only need to consider the design of the tables if we have a composite primary key. If we've got a composite primary key, we need to look at all the other non-key fields and ask ourselves, does each non-key field rely on all parts of the composite key or only some parts? If we've got a field that only relies on a part or a single field of a composite key, for example, that's called a partial dependency. As its name suggests, the non-key field is only derived from part of the primary key, and therefore it's no good for 2NF. It suggests that we'd need to break the table down into smaller tables. If, however, our table in 1NF does not consist of a composite key, we go straight to 3NF. Now in third normal form, we've got the fancy word transitive dependencies. What that really means is we forget the primary key and we look at all the non-key fields. Do we have a situation where we have a non-key field being derived from another non-key field? Remember, we want to ignore the primary key when we're looking at third normal form. Now, if we have a transitive dependency, what we've also likely got is a many-to-many relationship. And we're not allowed many-to-many relationships in 3NF. So if we consider our two tables here, where I've got the data in bold, these are the attributes or fields that we want to consider. The customer ID and the book ID, just pretend they don't exist at the moment. They're not important for 3NF. Now, the customers table is looking pretty good. Customer first name, customer last name, customer email. Now, none of those non-key fields seem to derive from any of the other non-key fields. They're, in other words, reliant on the customer ID if I was considering the primary key here. But when I look at the books table, the immediate thing I see is that conceptually speaking, this table contains data about more than one thing. It's supposed to be the books table, hence why I called my primary key book ID. But I'm storing data there about authors. I'm even storing data about genre, which again conceptually is a different entity. So if I look at this revised form, I've got the genre split into a different table, the author split into the different table, and we've still got the customer and now our smaller book table. When we look at the database notation down below, we can see at a glance that every single table now contains data about only one concept: a customer, a person, a book, a thing we're buying, the author, who wrote it, and the genre, a particular style. Now, if we look at the database design at this stage, we can see our four tables in our entity relationship diagram. But currently there are four flat files. They're not connected to any of the other tables in any way. But when we think about it, there are some natural relationships that exist between these tables. So for example, one customer may purchase more than one book, and one book, title anyway, can be purchased by more than one customer. Now, for the purposes of this example, let's say that each book is assigned one genre and one genre only. However, more than one book can obviously be of the same genre. Likewise, for this example, let's say that each book is written by a single author, but one author can write more than one book. So what we have here is a natural many-to-many relationship that exists between customers and books. For the purposes of this PowerPoint, the arrowhead represents the crow's feet, the many side of the relationship. I just didn't have that as an option in my arrow choices. So one customer can purchase many books. One book can be purchased by more than one customer. Now, in third normal form, we're not allowed a many-to-many relationship. That does suggest one of these transitive dependencies is taking place. We also have a one-to-many relationship between genre and books. One genre is assigned to many books, or a many-to-one relationship between books and genre. Multiple books can be assigned the same genre. Likewise, the relationship between author and books. One author writes multiple books. Multiple books can be written by the same author. Now, to get rid of this transitive relationship that occurs, the many-to-many relationship, what we need to do is split the many-to-many between customers and books. So let's get rid of it. We're then going to create a new table. This is a special kind of table known as a junction or link table. The junction table will typically contain the primary key fields of the two tables that it's splitting the many-to-many relationship. Theoretically, it can store additional non-key fields, but at the very least, it's got to store the primary keys of the two tables that we're separating. So in this case, we're going to go from a many-to-many relationship between customers and books to a one-to-many relationship between customers and orders, and a one-to-many relationship between books and orders. notice that the many side is always on the junction table. Now as a result, author and genre need to be linked not to orders, as we can see here, but to books like they were to begin with. So if I just update that in the diagram here, we've still got our one-to-many relationships existing between authors and books and genre and books, but now we have the many-to-many relationship between customers and books split into two one-to-many relationships with the aid of the special junction table that I've called orders here. If we look at the state of the database now, we see the addition of the junction table in the darker green. So here we have a table that consists of the primary keys of the customers table and the books table respectively. Now they're underlined, so customer ID and book ID collectively are a composite key field inside the junction table known as orders. But notice that they each have an asterisk next to them as well. So collectively, yes, they're the primary key, but and that will allow one customer, C1, Jane Smith for example, to purchase more than one book. But individually, they're also foreign keys. Customer ID is going to link this junction table to the customers table. Book ID likewise will link this junction table to the books table. Now the many side of a relationship is typically on the table with the foreign key. So as you saw in the previous example, we've got a many side between books and orders on orders. Likewise for customers and orders, the many's on orders. But we also have authors to books as one to many, many being on books. Likewise genre to books, many being on books. So if we see here, we've got in the books table an author ID, the many, is in the books table, and the author ID is going to contain the same data as the author ID in the authors table. Notice here I happen to have done a typo here. I didn't mean to do that, but author ID is spelt differently in the books table to the authors table. That's actually fine. As long as the data stored in the author ID of the books table is the same as the author ID in the authors table, who cares what the name of the field's called? Likewise, between genre and books, the many part of that relationship is in the books table. That's linking to the primary key of the genre table. When we look at customers and orders individually, customer ID is the many part which of the orders table, which links to the customer ID of the customers table. And then likewise, book ID is the many part between books and orders. So the book ID of the orders table, I should say, is the many part. That's going to link to the primary key books ID in the books table.